Hi, I'm Costel. In this video, I'll show you high-performance procedure to determine the absorption spectrum for an analyte. In our case, we chose to use total protein reagent. So, as known, all color compounds absorb certain wavelengths of ultraviolet or visible light and transmit other wavelengths. So this pattern of light absorption over a range of wavelengths is called an absorption spectrum. Each molecule has a characteristic, absorption spectrum that depends upon its structure. First of all, let's gather the equipment and supplies. We have everything in here now. So we have a Genesys 6 spectrophotometer. We have the reagent in here, total protein reagent, and we have the blank, what is called the blank, the reference, which is distilled water. So two cuvettes. The first one will be the reference one as the blank. We used to blank the instrument to get the I0. Remember the incident radiation intensity, and the second cuvette contains total protein reagent. We have in here the spectrophotometer. We left it for warm up, and now let's go and find the scanning. In the scanning test, we are going to determine to get the absorption spectrum. So in scanning in here, Genesys 6 spectrophotometer, we're going here. We'll have the name for the test. Let's say we are going to place A, let's say 1, enter. We are going to have absorbance mode, so measurement mode will be absorbance, wavelength, so we'll start from, let's think about 190 nanometers deep in UVC, remember that, and let's go to stop wavelength 1100, which is in infrared. That's very good. Okay, so we go down, sample positional auto 6. We have a carousel of 6 positions, 5 for samples, 1 for blank. And scan speed, let's go in a faster mode, let's say fast. Okay, interval, for interval, so we'll take the absorbance measurements from, using 5 nanometers in between, right? So a step of 5 nanometers will be sufficient for our procedure in here. Okay, so save test. Okay, accept name. Okay, so we have one run test. We'll go run test. It requires now to collect the baseline, meaning that we'll get the blanking for the whole range of wavelengths from 190 to 1100 nanometers. So blank, it requires blank. Position the blanking in there. We are going to take the cuvette, place it in the blanking here. The beam, the light beam comes this way here, and well, baseline, okay, blank, collect the baseline. It shows us the percentage of completed work, so 2, 4 percentages, and it goes this way until it collects the whole baseline between 190 and 1100 nanometers with 5 nanometer step, 5 nanometer step. So absorbance is at every 5 nanometer. We are almost done with the collection of the baseline, 99%. Okay, so now let's measure the sample. So it says that we can place the sample in cell 1. It already moved. Okay, wipe a little bit also the cuvette. So the light comes this way. So measure sample. Again, goes back and starts from one end, 190 with 100. So the process now is a little bit faster. Look at that. So it collects the data in a faster way. And at the same time plots the graph for the absorbance. Okay, this is the absorption spectrum. So we see that we have a peak in here about 600-700 nanometers. Oh, okay, so this is the second peak in UV. So this is the absorption spectrum of total protein reagent. Okay, so if you go into the AD graph, we can go in the cursor. Okay, so if we move the cursor, we'll see that 655, 334, 333, 337. So looks like 337, 337. No. Okay, 665 nanometers is the peak located on this absorption spectrum, and in here somewhere probably about 240 nanometers. So this is the absorption spectrum of total protein reagent done with a Genesys 6 spectrophotometer built by Thermo Scientific.